Hello, wonderful students. Welcome back to another day of Chem. Today we are going to continue that conversation, really dive further into the discussion of solubility curves. I know it was really briefly talked about in the past, so we're going to talk more about it and, what does it mean to be unsaturated, saturated, supersaturated? What do those look like? What does it mean to have a precipitate fall out of a solution? Things like that. So as we're looking at any of these tables, just keep in mind that it's important to remember that on your y-axis here, you're going to have your solute, so whatever your compound is. So today's demo, I have my Costco thing of salt here because I'm not at school where I have all my other chemicals. And in place of test tubes or beakers, I have a glass of water. And what you'll want to note is that is always per 100 grams of water, right? Because picture if this glass was full, I would be able to dissolve more salt in there. Or if there was less in here, I could dissolve less salt. And we'll talk about that right at the end of these notes. But for now, notice that all this is always per 100 grams of water or 100 milliliters, same thing. And then that is always on your x-axis is going to be your temperature. So it's also just important to kind of remember these relative locations. So unsaturated is going to simply mean below the line. And we'll talk more about, what does it actually mean for these to be below line. Saturated is literally on the line. And sometimes that makes students think that, oh, saturation doesn't happen very often. It actually happens a lot because of how this works. And so we'll talk about that. And then supersaturated is going to be above the line for whatever chemical you're talking about. And then again, I'm always going to add in this caveat with supersaturated, must be heated and cooled. I can't stress that enough. Heating it will actually a lot of times keep something saturated, which might seem weird right now, but just bear with me. So it must be heated and cooled. I can't stress that enough. And so again, we'll start to talk about what that means. And I'm actually going to use the saturation lab that you did or that you saw, typically with sodium thiosulfate. And we're going to talk about that here on this slide. So saturated lab example. Obviously, I don't have sodium thiosulfate here at home. I have Costco salt. And then I don't have a test tube. I have a glass of water. I know you're probably surprised. How does Ferris not have test tubes at home? I assume that's all he's ever doing. I don't have test tubes at home. So talking about this, let's just kind of use this to give some more real life examples before we delve more into just doing random problems, right? So let's pretend for a second here, and I'm actually going to jump this back and we'll use table salt as an example. Actually, you know what? Let's just pretend for the sake of this. Let's just pretend that this is NaCl, right? So this is going to be our table salt. And I'm just going to make up some random lines here on the side. Here's some lines I made up. The reason that I don't want to come back and use this NaCl graph, one, it's like there's a ton going on right now for this example. Also, you'll see that table salt actually has very little change in solubility. It's one of the lower ones in terms of change in solubility as you increase temperature. So I thought using a blank graph like this where you could just be like, insert random chemical, I figured this would be easier for the sake of just understanding and learning. So let's pretend for the sake of this that we're going to start right here. Again, this is going to be, roughly 25 degrees Celsius. We're going to consider that to be our room temperature, which again would be about the temperature of my house. So with that, if I take and I just dump in the tiniest little amount of salt. Okay, so that salt can be there, and I don't know, I have a pencil nearby. I don't have a glass stir rod, so I'm going to do, and I'm going to stir that up, and I can easily see that all of the salt is going to dissolve and disappear into this water. So with that, where we would be, and again, I didn't mass that out, but we might be like right here, right? I probably only dissolved a couple of grams of salt into there. So then we take, and I can just keep, and as I dissolve more in there, right, my temperature is not changing. So I can dissolve and I can put more and more and I can dump some salt in. And what's going to happen is I can stir this now. And as I dump that in, all I'm doing is this line is working its way up, working its way up, working its way up. And it'll work its way up to this saturation point. which on this fake graph, we can kind of follow that over, and we can see that it's saturated around 22 grams at 25 degrees Celsius. So what would happen now is if I stir this, a lot of times students want to say like, oh, you know what? He's stirring, and that salt's not dissolving. He has a supersaturated solution. No, we need to remember, supersaturated must be heated and cooled. So looking at this, even if I have salt sitting on the bottom here, which I do, I can't dissolve it, I'm still just sitting at a saturated solution. I have dissolved as much as I can into this 25-degree water. So now what I can do, I don't know, here's something I have sitting next to me. Here's my new stove. So now I can take and I heat that water up, and what's going to happen is I can watch that salt start to dissolve. And so what this will do is, let's say I heated this up to, I don't know, 35 degrees. So I heated it up to here. And so I'm just going to write that was on my, we'll put stove in quotation marks there. So what this would do is if I have enough salt in there, it's actually just going to stay on that saturation line until it hits that 35 grams. And if I can still see some salt in there, I'm going to assume it's saturated. If, however, maybe I had only added, what if I only had maybe 30, what would that be? Let's just say 25 grams of NaCl. If that's all I had in there, I would now just be back to having an unsaturated solution because it would have just heated up to this point and then worked its way over there. If I had had more than enough salt, so I don't know, let's pretend that I actually have 35. It would mean that I have 30 grams dissolved, 5 grams precipitate. And we're going to use precipitate here, just like you've seen in previous units, meaning it's just sitting at the bottom down there as a solid. So if I had 35 grams here, it would mean that 30 grams, right, could actually be dissolved in the water. This graph shows just how much can the water dissolve. That would mean I have 5 grams sitting at the bottom. So that is still just a saturated solution. When we say solution, we're talking about that aqueous solution, not the stuff sitting at the bottom. The water itself, the aqueous, is saturated. So now, that's where students want to be like, oh, it's super saturated. No, it's still not because we haven't cooled it. We heated it, we did half the work, we didn't cool it yet. So now if I grab a random box sitting around here, okay, here's my freezer. I take my water, I put it in the freezer. Remember, we have 30 grams currently dissolved in the water. 30 grams dissolved, 5 grams just sitting at the bottom. So now what we could do is if we take, and I'm going to use supersaturated as purple, now if we cool this down, and let's actually just say we cool this down to, I don't care, 15 degrees Celsius. What's going to happen is 30 grams was dissolved in there, and if we have a supersaturated solution, it actually doesn't follow this curve back down. This is where I say you kind of like cheat chemistry. It's going to follow that purple line back down, and then it's going to come down to here. So what would happen now is the solution can hold, I don't know, what would that be? Maybe 15-ish? Can hold 15 grams. If this feels like a lot, I'm going to encourage you kind of pause, rewind, go back and look at it. I know this is a lot I'm throwing at you and it's a little messy, but that's kind of the nature of how I can best explain this. So we had 30 grams dissolved, right? We cooled it down, meaning the solution cannot hold as much. The solution can only hold 15. So what we would say here now is that solution's really unstable. And so a lot of times what we can say is literally it can be like shaking the container or adding another crystal. Like if we were in the lab, you would literally take and like drop another crystal in there. And what you would see is all of this salt start to fall out of this solution and you would have a bunch more at the bottom of the container. That's called crystallization or precipitating out. And to know how much, well, it's just basic math. 30 was dissolved in there. And now the solution can only hold 15, so this difference precipitates out. Nope, I'm going to erase that 15 grams. Precipitates out, which in this case is going to be roughly that 15 grams, right? It's that difference from here down to here. We were at 30, now it can only precipitate out about, or it can only hold 15, so that difference, 15 grams would precipitate out. If you followed that, congratulations, you're pretty much good on today's notes. But for those of you that are still a little confused, let's just work ahead. So as temperature increases for most, so we can look at this table over here. Again, it's the same table we pretty much use every time. For most things, as temperature increases, what's going to happen? Well, solubility increases. That is, as you heat it up, just like if you heat up your tea, you can dissolve more. You heat up your Kool-Aid, you can dissolve more sugar. Exceptions, we're going to say covalent or gases. Again, I'm going through this kind of quick because I talked about this in the previous set. But you can see here SO2, actually as temperature increases, you can dissolve less. NH3, dissolve less. HCl, dissolve less. So covalent compounds or gases. Why? Simplest way that I can explain it, one picture, if you leave your pop in the car and it's hot out. What happens is those bubbles are going to rise out of the solution. The other way I explain it to students is you can picture like, your car tires shrink during winter, gases shrink during winter, those bubbles shrink when it's cold, so more of them can actually fit within that solution. So why? You can think of it, and again, these aren't perfect explanations, but you can think that hot bubbles rise out of solution. Or if you don't like thinking of it that way, you can think of it as cold bubbles shrink. Sorry, my iPad's kind of glitching right now. So more can dissolve within the solution. Something along those lines. Looking at this one, I would encourage you to pause and then try and answer these on your own. Once you've tried these, hit play and then see your answers. But I'm just going to start to work through them. So at 10 degrees Celsius and 70 grams solute in 100 grams of water, so the standard. And what saturation are the following? I'm going to do this pretty quickly. We can find the potassium iodine way up here. It says at 10 degrees, 70 grams of solute. So 10 degrees, 70 grams of solute. I'm just going to put a point right there. And then it makes it pretty easy to answer all these questions. Potassium iodide is simply going to be, we are below that line, so that is unsaturated. NaNO3, so sodium nitrate, we're still below that line, so that is unsaturated. NH3, we're actually directly on that line, so that one is going to be saturated. HCl, so hydrochloric acid, we're below that line, so that is unsaturated. Ammonium chloride, we're actually above that line, so this one's tricky. We're going to say supersaturated, but again, I'm going to assume that that it was heated and cooled, because otherwise you couldn't dissolve that much in there. And then sodium chloride, since that's above, I'm going to assume the same thing. Let's just say supersaturated, but same thing, assume heated and cooled. Next question, which solute is saturated at 90 degrees Celsius, 40 grams of solute? So I'm going to come down here on my x-axis. I'm going to see 90 degrees Celsius. I'm going to go up to 40 grams of solute. I'm going to put a dot. Hey, look at that. That is saturated. So that is NaCl, so sodium chloride is saturated at that point. At what temperature range is potassium nitrate? So I'm going to see potassium nitrate is right here. So that is going to be that line. At what temperature range is potassium nitrate supersaturated? So at 65 grams, so I'm just going to find 65 grams on that line, which is right about there. And so it would be anything lower is supersaturated. So with that, that looks like lower than 40 degrees Celsius. Are the following solutions of sodium nitrate unsaturated, saturated, or supersaturated? Again, same thing. I want you to try this, so let's have you pause the video, try these on your own, and then pick back up with it. I'm just going to work through the solutions right now. So 30 degrees Celsius, 90 grams. So I'm going to put a point there. In this case, referring to sodium nitrate, that is actually unsaturated. 70 degrees Celsius, 25 grams. That is definitely unsaturated for the sodium nitrate. 55 degrees Celsius, 140 grams. So somewhere around there. That is supersaturated. Again, we can add in our caveat that assuming heated and cooled. And then last one, 50 degrees, 115 grams. That looks to be right on that line. So that would be a saturated solution. Okay, if you cooled a solution of 90 grams sodium nitrate that is currently at 40 degrees Celsius down to 10 degrees Celsius, how much solute would precipitate out? So now we're getting into some of those harder questions. It's basically asking, kind of going back to our salt analogy here. You heat it up, then you cool it. What's going to happen? Like basically how much extra is dissolved in the solution right now that shouldn't be. So if you cool a solution 90 grams of sodium nitrate, so we're going to be following this line that is currently at 40 degrees Celsius and says 90 grams. So I'm going to just put a point there. 4 degrees Celsius, 90 grams. And you cool it down to 10 degrees. All we really have to do is we can tell it went from unsaturated, it would have hit a saturation point here, and then it crosses into supersaturated territory. So how much solute would precipitate out? Again, it's just going to be the difference. So the difference precipitates out. And my iPad's glitching. Okay, so with that, we can just simply look, I don't know, what is that difference? Going from about 90 down to 80. So we would say 10 grams precipitates out. Essentially saying you trick the solution into dissolving 10 more grams than it should have been able to because we have our 10 degrees down there. So what's going to happen? That 10 grams that you tricked it into is going to fall out of the solution, or what we call precipitate out. I can add in there kind of fall out. So it would sink back to the bottom of our container and you would see it sitting there. To what temperature would you have to cool a solution of potassium chlorate with 30 grams of solute at 90 degrees Celsius to make it supersaturated? Sorry, sometimes I need a minute to actually read through the question better myself. So I'm going to highlight our potassium chlorate line. So we're going to be focusing on that line in this case. 30 grams of solute at 90 degrees Celsius. So I'm going to find my 90 degrees, 30. So right now we have an unsaturated solution. And it says, to what temperature would we have to cool it to make it supersaturated? So I'm just going to follow down to here. Oh, that's going to be our saturation point. So anything lower is going to be supersaturated. So we look at that, that looks to be about 65 degrees. So I would just say 65 degrees or lower. If cooled further down to 10 degrees, so we keep following this, so it looks like we could handle 30 grams is what we would be at, and it can only support, I don't know, what is that, about 7 grams? And we were at 30, so that difference would be 23 grams would precipitate out. Because again, it's just the difference of what the solution can handle versus what you've tricked it into handling it by being supersaturated. How many grams of potassium chloride? Ooh, so now what you're going to see is this, that's 200 grams of water. Sometimes students make these a little bit harder than it needs to be. What it's really saying is, right here I have my, fine, here you have your glass of Kool-Aid. It's at 100 grams. And maybe you can dissolve one packet. Right? You can dissolve one packet in there. This question is basically saying, well, what if you wanted to double your amount of Kool-Aid, right? If you wanted to up this to 200 grams. Well, without doing any fancy chemistry, can you tell me how many packets you would need? Yes, that's correct. You would just double it to 2 packets. So if instead of 100 grams, we're going 100 grams of water, right? We're going to double how much water is in there. I'm just going to double how much can be dissolved. So in this problem, it says how many grams of potassium chloride. So I can highlight that line there at 15 degrees Celsius. So at 15 degrees Celsius, it looks like we can dissolve about, I don't know, 30 grams. But then it says per 200 grams of water, so this would have been in 100 grams. So in 200 grams, we would just simply double that to be 60 grams potassium chloride. And then the last problem, I think just instead of 200, it says half of the amount. So again, similar thing. If you had 100 grams, could take 1 packet of Kool-Aid. Well, then how much could half of it be? Maybe you just wanted to slam half a container of Kool-Aid instead, so that would be 50 grams. How many packets would you use? Yes, that's correct. You would just use half of a packet. So relating back to this problem, it's talking about HCl in this case. So I'll follow the HCl line, and it says at 30 grams, I'm sorry, at 30 degrees. So at 30 degrees, it looks like we could dissolve, I don't know, somewhere around 67 grams. So what we do now is if we could dissolve in 100 grams of water, we were able to dissolve 60 grams of HCl. It looks like what we would have to do is then in 50 grams would just be half of that, so 33.5 grams of HCl. All right, thank you for following along and learning with me today. If you have any questions or anything, please feel free to reach out.